It is not surprising that one of the most important tools for a technical writer is visuals, which include equations, formulas, figures, diagrams, drawings, illustrations, graphs, charts, schematics, maps, photographs, and tables. Visuals communicate a large amount of information quickly and efficiently. When you're designing visuals, be sure to include only information that directly relates to the mechanism description and is specifically keyed to the description provided in the text. Do not include visuals that do not match the mechanism description in subject matter or terminology. Also, avoid visuals that include too much or too little complexity for the level of discussion in the paper. These are general guidelines for using visuals. Include visuals in a technical paper only when you have a reason to do so. If you do not know why you are putting a visual into your paper, you probably do not need it. Be sure to reference a visual in the text discussion prior to its placement in the report. If the visual precedes its reference, the reader will wonder why it is there. Be sure to number and title all visuals. Ensure all visuals directly and clarify. Otherwise, enhance the text discussion. You need to integrate them into your report, not just stick them somewhere. That means that the labels and the captions used in the visual should match the text description that refers to the visual. For example, if you're describing the negative terminal of a diode, do not call it in the negative terminal in the text and the cathode in the visual. Document your visuals when they contain copyrighted information or represent borrowed ideas. Because visuals often get separated from the report, do not rely solely on notational or parenthetical documentation. Include a source line with the visual itself, usually under the visual's number or title. Then, designing your visuals, keep in mind the following criteria. Reproducibility. Design your visuals with the output process of your report in mind. If your report will be printed or duplicated in a single color link or toner, consider the fact when you are developing graphs or diagrams. Be especially wary of different colors that may look great on your video display but could print with exactly the same shades of gray, or even blend into the color of the paper on which the report is printed. A safe approach is to use pattern fills instead of color when the report will be printed or duplicated in a single color. Simplicity. Remember that the purpose of visuals is to supplement and clarify the information you are presenting. Some concepts are so complex that they do not lend themselves to visual presentation. Other concepts may need to be broken down into smaller components for effective presentation. Accuracy. Ensure that any visual you use accurately represent the information. Do not exaggerate the data by manipulating scales or misinterpreting relative sizes. Visuals fall into one of the following categories: equations, formulas, diagrams, graphs, schematics, tables, or images. Equations and formulas in mathematics are symbolic expressions that represent a rule, statement, principle, or a relation between two expressions. Formulas in chemistry are symbolic representations of atoms, molecules, and/or different chemical reactions. Diagrams are drawings that show a mechanism or its components. Graphs, however, display and represent sets of numbers, values, quantities, or proportions. Schematics are usual representations of the structure of a mechanism or process, and tables display the orderly arrangement of data or other information on columns and rows, and images or photographs provide accurate visual reproductions.